Good day, ladies and gentlemen. Welcome to another exciting session of the Distributed SQL Summit. In this session, we bring you the hottest news about our partnership with Amazon Web Services. I'm going to be your host for this session from Yugabyte, and today we have some exciting updates from our AWS collaboration. So let's dive in. Our guest today in this session from AWS is our ISV partner solution architect, Bo New. Bo, can you please introduce yourself for our virtual attendees? And also, maybe you could tell them how long you've been assisting us at Yugabyte in various partnership efforts.
Yeah, hi Richie, thanks for having me here. So I'm a senior solutions architect here at AWS. Has been in AWS for 4 years now. Prior to that, I was working on software development for the past 10 plus years in the field, and has been working with Richie and the Yugabyte team for the last year or so, working on different initiatives, which we'll cover in this.
Wonderful, wonderful. Thanks. It's been a pleasure working with you and the team, Bo, at AWS. As we jump into it, right, Bo, maybe you could start with your experience working with our solution architects and how this journey started, partnership journey started between AWS and Yugabyte.
Yeah, so Yugabyte started the journey with our team kind of started working on a foundational technical review. And AWS foundational technical review, which we call it FTR, enables you to identify and remediate risk in your software and solutions, whether your software is delivered as a SaaS solution or deployed by your customer as a managed solution. And the FTR helps you identify the AWS well-architected best practices specific to your software or solution. So that's kind of where we started. And then over time we evolved, and then there are other kind of partnerships with different integrations that we work on, which we'll cover afterwards as well.
Wonderful, wonderful. Thanks, Bo. But that's not all, right? Yugabyte also became an AWS Graviton-ready partner last year, and we've uh, we've been saving a whopping cost savings of using Graviton ARM-based compute. And if customers are looking or prospects are looking towards AWS cost savings, this is a partnership that's worth checking out. Would you mind maybe expanding on our Graviton-related partnership as well? Bo?
Yeah. I think this is in the 2022 where Yugabyte was certified for the AWS Graviton Partner Program. YugabyteDB Managed SaaS offering in AWS is now available on Graviton instance, right? And this means that Yugabyte customer can now take advantage of the performance and cost benefit of AWS Graviton Compute. AWS Graviton instances are powered by our Graviton processors, which these are customized design chips on this ARM-based processor. And comparing to the x86, just out of the box, if you compare the same instance type, it has around 20% price difference, lower price for the ARM Graviton-based instance. And on top of that, if we talk a little bit more on the technical side, each of the Graviton instance virtual CPU is actually a physical core, whereas in x86 it's actually a hyperthread, right, where you have two hyperthreads making up for one physical core, so that you actually double the amount of raw physical CPU that's in the server. So what that means is for a CPU-bound workload, that you're constantly hitting 100% of CPU all the time, for those type of workload, you can actually see extremely high benefit by moving from x86 to Graviton, where you can actually put more workers in parallel in the process, and then expect higher throughput. And then in the meantime, you probably just need less number of servers overall to complete the same task that you're currently doing. Each of the worker will still kind of have the same speed.
Mm-hmm.
However, you can pack more of these workers on the same instance if you are CPU bound.
Right, correct. And then we've noticed a performance boost of up to 40% with our performance engineering team's benchmarking efforts that they have spent time in the last year and a half that we've been testing. And also most recently, we've been seeing cost of savings going up to 22% on Graviton-based compute versus x86 compute resources. So it's definitely have been a very great partnership for deploying flexible Yugabyte deployments on the new generation of Graviton processors. And going from that, well, we do have an exciting update, an announcement to announce today, which is Yugabyte's new AWS service ready partner certification or status, right? I'm assuming it's called status. So maybe do you mind expanding a little bit about what that means to our customers or our prospects or uh, your customers that are on AWS today for to consume Yugabyte through AWS? What does that mean?
Yeah, I think you're referring to the AWS Service Ready program, where Yugabyte is just being certified for the AWS Private Link as a Service Ready partner. So I think it's a good time to kind of cover a little bit on what a Private Link is and kind of how it helps your end customer in this case, right? So if you look at traditionally, when you connect to a SaaS offering or API endpoint provided by a third party like Yugabyte, you will do that via the public endpoint. But then you probably know through public endpoint, there are other concerns because this is all via the public internet. The data you're sending out is public and is subject to kind of man-in-the-middle attack and things like that. And there's a lot of big enterprise customers that are worried about this. Data privacy is already at the core of everything nowadays. And with the private link, you can actually privately sending these data to Yugabyte endpoint now, and also retrieve data via that, so that everything is stay within private IP space. Nothing is sent via the public internet, right? And just to maybe dive deeper a little bit on the technology here, somehow people here might know that traditionally, when we talk about the private space, is kind of the VPC peering is probably the first thing come to your mind, and then over time we also have the transit gateway as well, right? That's in this space. Nowadays we have the cloud WAN. That's kind of the more easier managed version of the transit gateway nowadays, where you just don't need to have individual transit gateway connect to each other, where you can have it in a regional setup. But stepping back a little bit, like all these services initially is meant to have your internal company kind of work with different team and different services to communicate between each other, right? It's all private IP based. But one thing is, if you are a network engineer in that space for a few years, you probably notice that sometimes you run into a problem where you have conflicting, overlapping IP spaces, right?
Right.
Where in that particular case, it's just a very tough problem. You cannot communicate to each other because it's overlapping, and you can only have one instance for the one private IP. And in that particular case, um, that's a problem for both the VPC peering and also transit gateway, also now the cloud WAN. And in order to fix that, right, this is where the private link comes in, where you can actually kind of communicate via our private link privately, where private link actually creates an ENI in your own VPC, acting as the virtual private endpoint, right? So that you don't even see the kind of the other VPC hosted on the partner side, on Yugabyte side, on what their IP space is, right? So it's humbly abstracted from you, right? You just send traffic to your ENI in your own VPC, and then that reaches the Yugabyte in the background that you don't see, that is provided by private link. So that way you will be able to achieve the kind of the private connectivity, and also this is at a additional cost benefit as well, because traditionally, if you are running your servers privately in the private subnet, right, that in order to send traffic out to a public IP endpoint, then you have to send it out via the NAT gateway, right? That's kind of the only flow, and then it goes to the internet gateway and goes out. And then in that case, you actually have to pay for the NAT gateway cost, the data processing cost, right?
Mm-hmm.
And then if you are sending it to the same region, then you actually have to pay this additional kind of 1 cent of the sending from public endpoint to public endpoint. There's additional data transfer cost, right?
Mm-hmm.
But by sending it via private link, then you only pay for the private link data processing cost.
Right.
And on top of that, recently, this is somewhat recently, I think it's been a year or so, that we lowered where we eliminated the cross AZ data transfer cost when you are sending data via private link. So that even if you are sending, because for high availability, right, you want to deploy a private link in multiple AZs, right,
Mm-hmm.
where your workloads are in. And these are low balanced, right? because we recommend our customer to use the regional domain name rather than using the AZ specific domain name, so that in case of a failure of one single AZ, you are automatically kind of routed to the kind of working AZs. And in that case, in that particular case, when you send data across, previously you had to pay for the cross AZ data transfer cost, but now that's completely eliminated.
Yes. Yeah. I mean, in other words, right, VPC peering allows you to connect VPCs, enabling resources within those VPCs to communicate. Transit Gateway is a centralized hub that simplifies
Right.
VPC connectivity, making it ideal for large and complex network architectures.
Right. When you, it's around like if you, within a specific region, if you have more than a handful of VPCs need to talk to each other, right? In the VPC peering case, you have to do one-to-one direct, and it's going to be a mesh, right? And as the number of VPC grows, it's a big problem that it's hard to manage. And with the spoke hub model with the transit gateway, you only have to have each of the individual VPC connect to the one single transit gateway, and it's highly available within that region, right? You don't need to worry about having multiple of it for redundancy reasons.
Yeah, no, thanks for that overview of, the benefits of private link versus public endpoint and also understanding VPC endpoints in a customer VPC versus NLB and targets in service VPCs. Thank you for differentiating that. Naturally transitioning from that to private link, right?
Right.
And by becoming an AWS service-ready partner for AWS Private Link, Yugabyte now demonstrates that high standard that AWS customers expect, right?
Right.
Designation.
Yeah. So basically, this puts Yugabyte very close to the actual application that the customer is running, right? So this is just like another internal component of yours rather than a third-party component.
Right. So for Yugabyte Managed right now, the AWS private link allows us to meet requirements that our customers or our prospects ask for, where a system or an application shall not be accessible over a public network and should be closed from public access, right?
Right.
And that allows our customers to connect VPCs to AWS's service privately without exposing them to public internet,
Right.
basically improving security and compliance, and also will reduce network costs.
Right.
Right. So that, as a benefit, also we get the status of being a service-ready partner, which aids in both security and compliance. Thanks for that. Thanks for that update. But moving on, maybe let's transition to the next topic, which we were talking earlier, right? In a different conversation, we were talking about cross-region replication is critical for disaster recovery and redundancy, and maybe you can help with the differences and the benefits of synchronous versus asynchronous replication and the consideration for latency on both those choices, as we were discussing previous. Maybe you could also share some of your thoughts to the audience.
Yep. So step back a little bit at a high level, right? When you design a highly available kind of architecture, there are things to consider where you want it to be deployed in multiple availability zones, right? Each of the availability zone is one or more physical data center, right? So if there is a power outage or internet service outage, only one of the location is impacted, right? Then you will be able to rely on the other kind of AZs to take on the traffic, right? So that's kind of the within one single region, you have multiple availability zones. And then on the database side, where Yugabyte fits in here is you want to make sure your data layer is being replicated across these data centers, right? These multiple AZs in the process. And then there are different strategies there, right? There's the asynchronous replication versus synchronous replication, right? Typically for multiple AZs, you want it to be synchronous because you want to make sure there are more than one copy that has been committed before you respond the actual commit is acknowledged, right? Otherwise, if something got in the middle or something, when you write one copy, if you only have one primary copy, and then the primary copy AZ happen to just go down at the same millisecond, then you potentially lost that particular transaction, right? So there's some, and then the trade-off here, since the AZs are relatively close, is single millisecond latency in between, right? So that you can afford to wait until all the commitments are made, the multiple copies are made before you return, right? So you're only trading off one single millisecond. Compared to something like multi-region, in this particular case, different regions are spread pretty far. You probably see up to 100 milliseconds across different AZs, right? Across different regions, sorry. And then in that particular case, you probably don't, in the typical case, you probably don't want wait for that 100 millisecond extra latency to come back in order for your kind of API to respond, right? So that typically what we see is you will have synchronous replication between AZs in the same region, and then also asynchronously replicate to the other region, right? For either DR, or in some cases you may have active with different set of users in West Coast versus East Coast, right? And they will connect to the respective region, and then the data then will replicate across, right, for redundancy reasons, for DR reasons, right? So that's a common setup. And then I think Yugabyte actually is doing a very good job here, helping the end customer to make this configure very easy, right? Traditionally, if you were to do this in the application or in the database, depends on which database you're using, is might not be as easy, right? You may have to do a manual logic in your application to say write to different databases and have your application to make that commit happen before respond, right? And I think I heard from Richie that Yugabyte is actually making this seamless on behalf of the customer, right? So that's something really great that we're hearing.
Yeah, I mean, bringing it back to Yugabyte, right? Yugabyte's multi-AZ, multi-region architecture is designed to eliminate single points of failure. Components such as NLB, EC2 instances, EBS, and S3 interface points are all distributed across availability zones. And event of an AZ failure, Yugabyte still maintains a rewrite quorum and continues to operate seamlessly. That's part of our core value proposition. And thanks for getting into that piece of the conversation. Moving on, there are several lines of efforts that the teams between AWS and Yugabyte are working towards. To expand on a few of that, there has been something called as a co-build program, right? That both the SAs, the solution architecture teams here at Yugabyte and also at AWS have been working together in putting design patterns and AWS services that could work together in sort of a handshake fashion across, and the architectural patterns that would support a database, a fully distributed database like Yugabyte, which is always resilient and scalable for application development that are being built off of AWS platform. Maybe could you expand on that? Maybe could you expand on what the co-build program is and what have been you seeing across both the companies?
Yes. So I think the co-build is our partner team have an internal program kind of featuring these kind of partnership that we have, that we build together with partners, integrating with the services, right? I think something that Yugabyte did with our MSK, for example, right, the managed Kafka service, where you, in a typical kind of ETL workflow or data pipeline, you will have a streaming service like managed Kafka, MSK in this case, or Kinesis in the front, where you will be having your application server piping in all the data in real time into these streaming services, and then you will have a consumer that consumes from these kind of streaming service from MSK, right? And MSK itself is multi-AZ, right? So you will have multiple coffee for redundancy reasons, and then these consumers, you will deploy them in multi-AZ fashion as well. So throughout the pipeline, and then for this consumer, once you kind of like DQ from the MSK and then process it, and you will send the data then afterwards to process into Yugabyte and also maybe archive it on S3 in parallel, right? And that continuous flow everywhere, each component is multi-AZ, right? So that if one single AZ goes down, it will rely on the other AZ. And in this process, you also want to make sure that you have enough capacity, right? So it's one thing that you have everything spread around, but if you're always occupied 100% of the capacity, then when one AZ goes down, you may lose. If you have three AZ, then you're losing like 33% of your capacity, right? Then the other AZ will be overloaded if it falls over. So you want to make sure your capacity is planned for a AZ going down at any given time, right? To address that.
Yes. Yeah. And I think besides that, the data streaming and the analytics, what Yugabyte and Amazon, we are building services with not just MSK, but also with Redshift, right? As the data
Right.
gets landing into Redshift for analytical workloads to be consumed. We're writing complex code for ETL applications and services that, provide CDC-based data movement for streaming real-time data or near real-time data changes through MSK is one of such initiatives that we are collaborating together in putting how-to guides and architectural patterns for how to support these services in unison.
Right.
Need
Yeah,
that.
so MSK is kind of in the front where after data gets into Yugabyte and into S3, then you do the post-processing, and then there's connectors in between Yugabyte and Redshift as well, right? If you want to do a little bit more analytics-oriented workload rather than the kind of database queries.
That's great. As a benefit of AWS Service Ready program, I know there are quite a few things that come with it. Maybe, Bo, do you want to take a quick minute to expand on that?
Sure. As a benefit of the AWS Service Ready program, the AWS Service Ready program team will be working with our customer, promote the customer, in this case, Yugabyte teams and their offerings by adding Yugabyte to our partner website, the APN partner solution finder and the APN blog. So, and in fact, I'm working with Richie right now, working on several blog posts together on different topics that we touch on, like the Graviton, and also some of the co-build initiatives as well. And this will help Yugabyte to raise the awareness, or Yugabyte end user to raise the awareness of Yugabyte solutions in this space.
Thank you, Bo. Thank you again for sharing your expertise and your insights today. You and along with the other SAs at AWS have been a tremendous help in helping us figure what would make sense and what our customers would benefit with the plethora of AWS services that are in the cloud. It's been an illuminating conversation, exploring networking solutions all the way to collaboration opportunities that are currently in the works. We look forward to seeing these continued innovations between Yugabyte and AWS partnership. And to our audience, thank you for joining us. Stay tuned for more exciting developments in the world of distributed SQL. Until next time, thank you for your support and keep innovating.